All right, video number 2 for this section, or this week, last week, whatever. Um, Surface area spheres. Okay, this is luckily a pretty easy section. The formula is pretty basic. So the formula we got is just the surface area of a sphere is 4 pi r squared. So again, the thing to remember is it's surface area, so that's going to give us r squared, not volume. Volume was cubed. Okay, so we're back to r squared again. And then all it is you take whatever shape you have. So like here we go. This is a composite figure. Let's skip straight to some of the examples. Boom, homework. This is what I want to do. Okay, so let's say look at this guy. We want to figure out the surface area for this. Okay, so the formula again, 4 pi r squared. So for this, the diameter is 16, which means the radius is equal to 8. Okay, so I want to do 4 times the radius squared. So I'm going to say the radius squared is 64. Okay, so it's going to be 4 times 64 pi. 4 times 64, 2 times 64 is 128, so 4 is 256 pi. And we're done. That is all there is to those. Okay, let's do this guy real fast. So 21. Okay, so it's already the radius, so we want to square the radius, which, why? I have no idea what 21 squared is. Do you know what 21 squared is? No. So we're just going to use our handy dandy calculator. So we're going to say 21 times 21 equals 441. Perfect. And then we say times 4. 1764 pi. 1764 pi. Okay. That's surface area for spheres. Okay, so they do throw some tricky ones in here for you. Okay, so like these guys, we have the area of that circle in the middle, okay, is 81 pi. So real fast, what is the area of a circle? Area of a circle is pi r squared. Oh, you can't see that. Oh, yeah, you can. So pi r squared is the area of a circle. What's the area of a sphere? Well, it's 4 pi r squared, right? So surface area of a sphere is 4 pi r squared. So all I'm going to do is take this number or this number and multiply it by 4. Okay, so what's 81 times 4? I don't know. Let's see. Let's call back our friend, the handy dandy calculator. 81 times 4. 324. So this guy is just 324 pi. Okay. So there's that. Let's see. Let me look at some of these other ones. We'll do a composite figure. But first, let's go up to this hemisphere. Okay? So we want to figure out what the area of this hemisphere is. No, that one doesn't give me the area. Here we go. I knew there was one with this surface area. Okay, so we want to figure out the surface area for this closed hemisphere. Okay, different than a dome. And so that means we have to include the bottom. Okay, so the area for the sphere, surface area of the sphere is 4 pi r squared, right? But we only want half of it because it's a hemisphere. So what we're going to do is we're going to take that surface area and cut it in half. So the easy way to do that is if I look at my formula, we say 4 pi r squared, divide that by 2. Right, and we end up with the formula we can use for hemispheres, which is 2 pi r squared, right? Because 4 divided by 2 is 2. Okay, so if our, what's that word? Diameter is 8, the radius must be 4. Okay, so 4 squared is 16 times 2 would be 32 pi. Okay, so our hemisphere is equal to 32 pi. We're not done because we need the circle that is covering the bottom. Okay? And that is just pi r squared because it's just a circle. So we're going to say 32 pi plus pi r squared. We said the radius was 4, so radius squared is 16, so we have 16 pi. So we have 32 pi plus 16 pi, and that's our circle. And so our total area is going to be 48 pi. And that's the surface area for that. Okay, now let's look at some of these other problems. Let's look at some of these composite figures. So if I look at, whoa, I have to move the camera for that one. This guy. We want to figure out what the area of that figure is, the surface area. So looking at it, first I want to take it apart and figure out what I've got. Well, I've got two hemispheres. Well, two hemispheres makes a whole sphere. So I have one sphere, and then I have a cylinder. But I don't have the top and bottom of the cylinder. I just have the part that's wrapped around the side. So if you remember, when you unwrap a cylinder, it makes a big rectangle on the sides, right? You have that one rectangle, and then you have two circles. So we just have the rectangle, okay? So let's do the hemisphere first because that's the easy one. That's what the two hemispheres. So since it's one whole sphere, that's just 4 pi r squared. Radius is 2, so it's going to be 4 pi times 4, or 16 pi. Okay, so that's our sphere. So our sphere is equal to 16 pi. All right, now we just got to do this part. So we got to remember, how do we figure out, so it's a big rectangle, right? So we know that one side is 5, but how do we figure out that side? Well, that side is what's wrapped around the outside of that sphere, or the circumference. Circumference was equal to 2 pi times the radius. So if the radius is 2, 2 times that is 4, so that's going to be 4 pi. Now we have that shape. 5 times 4 pi is going to give us 20 pi. Add those two things together, and we have 36 pi. Really, that's all composite figures are, is just figuring out how they're working together. So I'm not going to do these other ones because I want to keep this video short. So this guy, look, I have one huge cylinder, right? So we know the radius of that cylinder is 8, okay? And we know the bottom is going to be 8. And so if we want to do the wrapping around the outside, it would be the circumference. So 2 pi r, so 16 pi times 3. That'll give me the outside. That'll give me the rectangle. Okay, the top and the bottom are just circles, so pi r squared, right? So we have 64 pi, 64 pi. That's your cylinder. But they've carved a scoop out. Like, to me, it looks like somebody took an ice cream scoop and just went whoop. So we have to deduct or subtract that hemisphere. So the hemisphere is... Oh, wait. No. I'm doing it backwards. Okay, this one is a little trickier. So, you know what? We're just going to write it out. So we did the surface area of the cylinder. Okay, surface area of the cylinder, what did I say? It was 8 pi. So 16 pi was the circumference times 3. So 16 times 3, 32, 48. So the square is 48 pi. Okay? We have the top and the bottom. All right, so the top and the bottom was 8 pi r squared, so we have one of them is 64 pi, and then the top is also 64 pi. Do a little circle so we know this is the top. 64 pi, but we have to subtract that circle that was on the top, right? We cut that out. So that's pi r squared, so 2 squared is 4, so 4 pi. So we're going to subtract 4 pi. Okay, so that top area is going to be 64 minus 4, which is 60 pi. Okay, so this is why I did this one. This one gets a little tricky. So we now have the outside, the bottom, and the top missing that circle. But since it's surface area, there is still more surface. It's the inside of the scoop now. Okay, so we have to figure out what that is. So to figure out that, it's a hemisphere. And so we're just going to figure out the hemisphere part. So that is going to be, what is it, 4 pi? 4 pi r squared is for a sphere. So this is half of it. So it's going to be 2 pi r squared. So r squared is 2 squared, which is 4. 4 times 2 is 8. So then we have this little dome is going to equal 8 pi. And so now we add all that up. Right? We've got our wrapping around the outside, that's 48 pi. We have the bottom circle, 64 pi. Top circle with the hole taken out, 60 pi. And then the scoop gives us 8 pi. So we add all that up. So let's see, 48 plus 64, that's going to be 112 plus 60, 172 plus 8, 100 and, what am I doing? 180 pi. And there's our answer. Okay, so that's our composite figure. So again, look at this one. It's going to have a similar, you can't see that one. Looking at this one, it's going to have a similar thing because you have to calculate the surface area of that inside piece. You're going to subtract the circle and add in that surface area. Over here, we just have a rectangle plus that surface area. Okay? You will subtract the circle on the bottom, but you'll add it in. So they're all basically the same. Okay? Okay, so these composite figures get a little tricky, but hopefully this helped walk through it. That's why I did it after I saw that it's more complicated than I thought. Okay, that's it. Those are your 2 videos for last week, but there you go. Have a good one, guys.